Welcome to the Messages channel. Today we're going to have a look at how to identify a tapered and a parallel thread, as well as looking at a couple of facts around threads too. Fittings with threads will either have an internal or external thread. If the thread is internal, it's referred to as female, and if the thread is external, it's referred to as male. Both male and female threads can either be tapered or parallel in shape. Tapered threads gradually narrow along their length, meaning that they're wider on one end and narrower on the other, similar to the shape of a cone. Parallel threads stay the same width along their entire length, with no change in diameter. A quick tip for if you're unsure whether a male fitting is tapered or not. You can place it on a flat surface and you'll see that the cone-shaped thread sits higher than the fitting body. When you choose your thread, you'll need to know the standard. Two of the most common standards are British and American. It's important to know which standard you need because this will affect how well the threads seal together. One way to tell if you have an American standard is to look at the external and internal thread, as both of these are flat. Also, the thread angle is at 60 degrees, which is different to the British standard. The British standard isn't that much different from the American standard. The external and internal threads are curved instead of flat, and the thread angle is at 55 degrees instead of 60 degrees. Threads are measured in threads per inch. This can help determine how many rotations are required when tightening a fitting. Now that we've had a quick look into how to identify a thread, let's look at how parallel and tapered threads can fit together. Parallel male and female threads are designed to fit together. They are sealed with a dowsy washer. Their shape maintains a consistent diameter, unlike tapered threads. When two tapered threads connect, they compress much tighter together due to their cone-like shape. However, if you are using tapered threads, they're not ideal for systems that need to be dismantled and reassembled often. The repeated compression can cause threads to compact and become damaged. Tapered male and parallel female fittings are the most common combination used across Europe. They can also be disassembled for systems that require frequent servicing. If you try to use a parallel male thread with a female tapered socket, it's just not going to work. The two diameters are very different from one another. You would end up just damaging the thread and the sockets. When threads are damaged, it's known as galling. Quite often, the threads can become deformed when two incompatible threads are compressed together. When fittings are fastened together, friction is created between the threads, which can increase the risk of the joint not sealing tightly enough. To address this, a variety of sealants can be used, each suited to different applications, including selecting the appropriate sealant for the material of the fitting. Sealants can range from compounds and tape to more traditional materials such as cotton and hemp, and we'll cover these in more depth in a future video. A common solution for reducing friction caused by debris and imperfections on the threads is to use PTFE tape, also known as Teflon tape. Not all PTFE tape is the same, and it's important to choose the correct one. That way you can ensure a safe leak-free seal that handles the correct temperatures and pressure depending on the medium you are using within the system. When it comes to wrapping the tape around the thread, it's best to remove any dirt and debris. You can do this by using a steel brush, but don't scrub the thread, just lightly scrape it. When you wrap the tape around the thread, leave at least one thread available. That way, when you screw your fittings together, the fitting thread will have something to latch onto. It helps to put your finger through the hole in the spool and have the tape on the underside as you wrap it around the thread clockwise. Keep the tape taut as you wrap it around the thread. Once you're happy with it and you've wrapped it around a few times, smooth off the tape against the thread with your thumb, but don't press too hard though because the tape can rip. Here's an example of why you don't want to wrap your tape at the beginning of the thread. When you put your fittings together, this excess tape can break off and contaminate your system. And that brings us to the end of our video. If you found this video useful today, let us know in the comments and let us know what type of content you'd like to see next. Thanks for watching and I'll see you in the next video.